Welcome to our 9.2 video on significance tests for proportions. So last section in 9.1 we learned about more of the general concept behind significance tests and some of the pieces to a significance test, like writing out your hypotheses, what a p-value is, and how you might conclude depending on what type of p-value you get. In this section we're going to get a little bit more specific and talk about how to actually conduct a significance test for a proportion situation. We will talk through one example in this video, but we're not going to do a ton of examples just because it's hard to keep the time on these videos short. But instead, I've made sure to put extra bonus videos throughout the Schoology lesson that have specific examples similar to what types of problems I'm asking you to do. So if you want some more examples, just view those videos. I think those will be more helpful than me creating a hour-and-a-half long video here. Okay, so back to our situation from the 9.1 video, where we had the free throw shooter who claims he's an 80% shooter, and we had a sample where he shot 53 free throws for us, and he really only made 32 out of 50 of those shots, which really is only 64%. So we're going to make a significance test for this situation. So first, we talked about this last video, but our null hypothesis, which we use h sub 0 to represent, would be that p equals 0.8. Basically, that he's telling the truth, he's actually right. Our alternative would be that maybe he's not right, maybe he's exaggerating. And that's what we think is probably happening here. And so that's our alternative hypothesis, h sub a. And we say p is less than 0.8. P stands for our true proportion, our population parameter. Out of all of the free throws he's shot, he's an 80% free throw shooter. Okay. So what we want to do is we want to start our problem by stating our hypothesis and defining what p is. That's kind of the first step for a significance test. Okay, next. Okay, so just like in our confidence interval chapter 9, where we saw how to do confidence intervals by hand, but then we learned how to do them with a calculator, this is going to be kind of similar. So if we were going to do this by hand, we would need to find the standard deviation. We use the same formula that we've seen already for standard deviation. And we fill it in with the square root of p times 1 minus p over n. P is the assumed value. So we're going to assume that p is the value that they gave us, aka 0.8 or 80% in this example. That's how you find the standard deviation. And then the mean, we assume, is what he told us. So we would say our mean or our true proportion is 0.8, and our standard deviation in this case would be 0.0566. Okay, next. Once we've found the mean and standard deviation, we're ready to actually find our p-value. Turns out we can find our p-values using strategies that we've already learned. So we can say the test compares a statistic calculated from a sample of data with the value of the parameter stated by the null hypothesis. The values of the statistics far from the null parameter value in the direction specified by the alternative hypothesis give evidence against the null. What does that mean? Well, if I want to find a p-value, I'm going to use this formula, which is really very similar to a z-score. Oops, undo. How do I do? Okay. So we measure how far the statistic, this is our data, is from the parameter, the assumed value. And we divide it by the standard deviation. This is very similar to the z-score formula, which is x minus mu over sigma, right? We're taking the value that we found, the data from our sample, subtracting the assumed value, which is like our mean, and we're dividing it by the standard deviation. Once we do that, we'll see on the next slide, or once we do this, never mind, it's not on the next slide. On this slide, once you do this, you find that value, and then you can use your normal CDF to actually find the probability by plugging it in and doing, less than or greater than and all of that. Or we can use our calculator. Here's what you see if you actually do it by hand. You can find that z-score. It's negative 2.8 by plugging in those values. And then using our normal distribution math, you can either do it by hand using the table or using a calculator. We find that the probability is 0.0023. So if the null hypothesis is true and the player makes 80% of his free throws, in the long run, there is only a 2 in 1,000 chance, right? Because this is the thousandths place, right? Tenths. The first 0 is tenths. The second 0 is hundredths. And this 2 is in the thousandths. So we say 2 in 1,000 chance that the player would make as few as 32 out of 50 shots. So very unlikely. Okay, if we wanted to do something like this on our calculator, this is how you're going to do it. You will go to the stat button and then tests, just like you did for doing confidence intervals, but this time you're going to find the 1 proportion z test function, which is the 5th option. So it's important that you click on that one. There's lots of options. Make sure you click on the right one. Then you will enter p sub 0, which is the stated value you're testing. That, in this case, is just p. So if you're trying, for this example, p would be 0.8. Then you put in x and n. X is the number of successes from your sample. So maybe I should add that here. Sample. So in our case, so I'll put this in, it would be 0.8, would be p sub 0. In our case, we were told that he made 32 of the 50 samples, so 32 would go in for x, and 50 would be the sample size. You'd plug in those values, you'd pick what type of test you wanted to run. So if your null hypothesis said, or if your your alternative, in this case our null hypothesis was h sub a, we thought that p was less than 0.8, you're running a less than test, you would select the middle one. If it had been the opposite, if it had been p of a is greater, you would have done the end one, and if it was does not equal, you do does not equal. So you select that, and then you can go down and you hit calculate, and you'll find your p-value. Okay, so now that we know the mechanics, let's talk about the structure of what you need to do if you're actually doing an FRQ or something on the AP test or something for me. First, you're going to state what your hypotheses are, your null and your alternative hypothesis, and define the parameter. So what is p? What is that standing for in this case? You'll figure out what conditions you need to check based on the type of inference. This is the general steps for all types of significance tests, not just parameters. So you'll figure out which conditions you need to check based on the situation. You will actually find the p-value either by hand or using your calculator, and then you'll make a conclusion based off of that p-value. So if you are doing a significance test for a proportion, the conditions that you're going to check are the same as the conditions you would check for a confidence interval. You're going to check that that the sample was taken randomly. You're going to check that the sample is less than 10% of the whole population. And you're going to do the large counts, which this time we're going to use p sub 0, which is just p. So for our case, for our example, we would have 50, because our sample size was 50, times p sub 0, that's the assumed value, that's 0.8, and we would have 50 times 1 minus 0.8, which really would simplify to 50 times 0.2. So those would be the conditions we would need to check for a hypothesis test of a mean, or a proportion, which would be what you would do in the step 2 from the last slide. Here is a restated version of the z-score and how you would plug it in. You take your sample minus your proportion over the standard deviation, and then this is what your hypothesis would look like, or what the picture you would draw if you were doing this by hand would look like based off of your hypothesis. Again, we're going to use a calculator most of the time, so probably not the most important thing, but it's still good to see. There is one special thing you'll need to know for a two-sided test if you're doing it by hand. Two-sided tests basically say that it's both greater than or less than, right? You just want it different. Doesn't matter if it's above or below. If it's anything different, it's wrong. What you have to do is you have to find the area of both tails. When we find a p-value by hand, we are only finding the area under one of the tails, and so we have to account for this in any two-sided test. How you account for that is just by finding a single-sided test and then just doubling that value. Luckily, normal curves are symmetric, so the area on one side of the test will be equal to the area on the other, and you can simply double it. If you're using your calculator, it'll take this into account for you. Okay, so one connection between confidence intervals and hypothesis tests is that they kind of answer questions that we might have at the same time. So once you do a significance test, that's telling you whether we reject or fail to reject the null. If you reject the null, you are wanting to figure out what the actual proportion might be, and that's where a confidence interval can come in handy. Here's an example if you'd like to look over it. So what we see is that the link between confidence intervals and two-sided tests is really strong. A 95% confidence interval gives an approximate range of p-values that would not be rejected by a two-sided test at an alpha equals 0.5, a super common level. So basically, if you're in the interval, you would fail to reject the null, and if you were outside of that interval, you would reject the null. So there's really a connection there. So now, before we finish this video, we're going to talk more about type 1, type 2 errors, and specifically the power of a test. So we learned in the last video that a significance test makes a type 2 error when it fails to reject the null hypothesis that is really false. There are a lot of different types of alternatives that we could create, so we usually just pick one, basically whatever we specified in the example. And we say that the power of a test against a specific alternative, whatever you picked for that problem, is the probability that the test will reject the null hypothesis that should have been rejected at a chosen significance level when alpha, when the specified alternative value of the parameter is true. So more on type 2 errors and the power of a test. A significance level of a test, that's alpha, is the probability of reaching the wrong conclusion when the null hypothesis is true. So saying that it's false when it's actually true. The power of a test to detect a specific alternative is the probability of reaching the right conclusion when the alternative is true. So rejecting the null when the null is false, basically. We can just as easily describe the test by giving the probability of making a type 2 error, sometimes called beta. The power against any alternative is 1 minus the probability for the alternative. That is power equals 1 minus beta. Now, you're not usually going to find beta or the power from scratch. You'll usually be given one and asked to find the other. If you're given the power, you can simply solve this equation. If you're given beta, you can just do 1 minus beta. One last example gives kind of an example behind what power is. So basically, this is showing us that we're testing for a potato chip producer that wonders whether a significance test of p equals 0.08 for the null versus p is greater than 0.08 based on a random sample of 500 potato chips has enough power to detect a shipment with, say, 11 blemished potatoes in it. So if we look at this example, we see on the graph that if we let alpha be 0.0, we see that we would reject the null in the shaded region. So basically, what this is saying is that with alpha at 0.05, our sample yields a p-value big enough or small enough that we would, not big enough, small enough that we would reject the null when we needed to reject the null about 75% of the time, which is the power of the test. Okay, that is it for the 9.2 video. Again, there are more specific example videos in the Schoology lesson. So watch this video, take some general notes, and then watch extra example videos as you need. But if you feel like you've got it, go ahead and work on those problems. Have a good day.